Every nuclear aircraft carrier ever to sail has had its zirconium and other reactor-grade materials provided by our site here in Albany, Oregon. We're also involved in commercial nuclear sites, including the very first one, the shipping port plant, where our zirconium went into part of the core. Today we support commercial nuclear power around the world. And even though the United States has the largest number of reactors in the world at 104, the growth is in the rest of the world, where they're using nuclear as part of the equation to help provide stable, low-cost, environmentally friendly power. Wherever there is nuclear around the world, that's where we are. If it flies in space, we're on it. Every satellite, every space shuttle, the Mars lander, lunar rovers, everything that's been flying in space, we're on it. International Space Station. One of the materials we make that goes onto that is an alloy called C103, used for thrusters and other shielding materials that go on these rockets and satellites. Apollo 11 had our C103 thrusters on it when it landed on the moon. If you have ever flown on a commercial airplane, our material's been there in the hydraulic system. Virtually 90% of all commercial aircraft in the world has our material in the hydraulic systems today. We're also expanding our reach into the aerospace industry with some advanced materials and other product forms. Some of the advanced materials we're working on are called shape memory alloys. These are alloys that remember their shape and can be used in a variety of applications, including implants in the human body, in the electronics area, as well as next generation actuators on aircraft that result in significant weight reductions and fuel savings. We produce that here. If you've ever been in an MRI machine, our material's been in it. Virtually 90% of the world's MRIs have our niobium-based alloys inside them in the filament wire that make up the very large magnets that create the large magnetic fields that peer into our bodies. High energy physics. Any of the atom smasher projects that go on around the world, including this one, the Large Hadron Collider, built by CERN. You may have read that in the Dan Brown book or seen that in the Angels and Demons movie starring Tom Hanks. I can assure you of two things. Number one, it doesn't produce antimatter. And number two, despite the popular reports that when they fired it up, it didn't create a black hole that devoured the Earth. So we're pretty happy with it. But all of these projects that go on around the world, we're there. These are extremely high technology projects that involve years of development and work, and typically involve consortiums of governments and countries and research labs from around the world. Our scientists, our people are involved in every one of those. And we are usually the principal supplier of some of these high performance materials. Chemical processing. Most of the, I would say, high performance or high demanding, extremely corrosive chemical environments around the world use our material. These are largely zirconium alloys, some are titanium. This one pictured here is a pump casing produced by our foundry at the Albany operations. But these components we produce not only raise the factor of safety for that plant, but usually last the life of the plant. You put these components in, you don't replace them again until you tear the plant down. Medical implants. We also go inside the human body with our materials. In this particular case, this is a knee implant and a very special alloy that we produce at Huacheng, which is a derivative of a nuclear alloy, has been selected for use by Smith & Nephew. You may have seen some of their commercials on television, but this is what they're talking about. This knee lasts 30 years. It's the first material ever certified by the FDA to last more than 30 years in the human body. Most of the other implants last 10 to 15 years. What makes it last that long is that material, that zircon-niobium alloy that Smith & Nephew calls oxinium. Very special properties that produce a very glass-smooth surface on it so that it doesn't wear out that polyurethane cartilage replacement that's in the human body. Nuclear fusion. We usually see these in movies, science fiction books, and other things, but there's a consortium of companies, research labs, government labs around the world that are coming together to take the next step in evaluating fusion as a viable energy source. And if you remember the difference between fusion and fission, fission is what's used today in existing nuclear power plants. That's where you bombard uranium with neutrons, it decays and creates energy. Fusion is basically the energy from the sun. That project is underway now, and we again are a principal material supplier to that project. Matter of fact, all the countries that are involved in this project are buying material from us to support that. Something else we're very proud about. This is home here. We have, as one of probably the larger industrial water users here in Linn County, certainly, and probably one of the larger ones in the state of Oregon, we have some unique challenges in how we draw water from the Willamette River and how we treat it before we send it back to the Willamette River. The cities of Albany and Millersburg had similar challenges in that the industrial or the municipal wastewater they produce typically is a higher temperature and has some organics in it that make it difficult to treat prior to going back into the Willamette. Well, a few years ago, some of our people, in concert with the cities of Albany and Millersburg, began working on a project to establish an artificial wetland that we would build that would allow the combination of our industrial water with the municipal waters from the cities of Albany and Millersburg to come together and go through this artificial wetland and end up back in the Willamette River cleaner than when we took it out. That project's underway right now. We're providing over $6 million of funding to that, combined with city, government, and federal funding. This project will essentially be complete next year and should be actually operational probably by the end of 2012. We'll begin planting this spring. This project has received a lot of attention for our area here. Civil Engineering Magazine, MSNBC, we just heard that we're a finalist from a National Environmental Association award in the U.S. This will be a place where engineers, engineering students, and others from around the United States as well as the world come to study this type of collaborative venture, which is the first that we know of in the world. So I think this is something we can all be very proud of. At the end of the day, we're going to be taking Willamette River water and we're going to be sending it back cleaner than when we got it. And at a temperature that's not going to affect any of the salmon habitat or anything else. So that's, in our book, that's a good day. So that's my presentation. So I'll be happy to take any questions. Yes, sir.
John, can you comment on the new scale packet reactors that's coming out of OSU? You're working with those folks, I would imagine, somehow.
Yeah. Glad they turned the lights up, John. I can see it now. John's question was on the new scale reactors. There is a whole new technology that's being looked at in the United States and gaining a lot of political momentum. And these are called small modular reactors. Instead of building an $8 billion massive nuclear power plant, you can build something that's in the